Greetings, YouTube. Beautiful Mind here with another question from College Algebra. This comes from our same text, question 1.2, question 21 out of the back of that section. So this question says, when Fritz drives to work, his trip takes 54 minutes, but when he takes the train, it takes 30 minutes. Find the distance Fritz travels to work if the train travels an average of 24 miles per hour faster than it's driving. Assume that the train travels the same distance as the car. Okay, so let's draw a picture to get a sense of what's going on. So say this is his home and he's traveling from home to work, right? So this is work, this is home. So when he drives to work, so let's talk about, so if we're going to do the car, I don't know, for some reason he's driving a red car. Why, I don't know. But he's driving his car to work, all right? So when he drives to work, his trip takes, and we're going to go like this. When he drives to work, it takes 54 minutes. So the time by car equals 54 minutes. But when he takes the train, it's 30 minutes. So the train, we'll just do something quick for the train. I don't know, our train is going to be, let's go like this. Like that. We're going to do something like this for the train. I don't know what kind of train he's on. He's just on a train. Okay, that's our train. So it says that when he takes the train, it takes 30 minutes. Okay. So when he goes by train, so the time by train equals 30 minutes. Now, okay, we'll talk about that in a moment. It says find the distance. So our unknown, the question is the distance. So the distance is our x. It says find the distance Fritz travels to work if the train travels. So the train. It says the train. So the rate of the train. It says an average of 24 miles per hour faster than the driving. Oh, that's not the time. Sorry, that needs to be the rate. I got that all mixed up. The rate of the train needs to be what? The rate of the car plus 24 miles per hour. Excuse me. The rate of the car plus 24 miles per hour. Okay, let's see. So the rate of the car, we're just gonna call that R. So I know it looks like we have two variables. We're gonna organize this the same way we did one a minute ago. Okay. So first thing, we should convert these minutes. We need to put these in terms of hours. So we're gonna put this over 1. And so to do the conversion, we're going to do the following. How many minutes in an hour? Where there's 60 minutes corresponds to 1 hour. So then when we do this conversion, we're going to say 54 divided by 60. Hey Siri, what's 54 divided by 60?
54 divided by 60 is 0.9.
Okay, so 9/10. So this is 9/10 of an hour, right? And then if we convert 30 minutes to an hour, you know that. So again, 60 minutes is to 1 hour. Units of minutes cancel. We're left with hours, so that's half an hour, right? Okay, so we're going to do something similar to what we did last time. This is going to be about the car. This is going to be about the train. We're going to say rate times time equals distance. Okay. So the rate of the car, we just called that R. The time for the car was 9/10 of an hour. So 0.9 hours. So then the distance when he travels by the car is going to be 9/10 R. All right. When he goes by train, the rate that the train travels, let's see, is going to be the rate of the car plus 24. So to be a little bit more consistent, let's do the following. So, oops, didn't mean to do that. We want to copy. Yes. So the rate of the train is there. It's going to be the rate of the car plus 24 miles per hour The time for the train was half an hour. So let's get a copy of that. Copy, paste. So the distance traveled by the train is basically going to be half of the rate. Let's copy this. And like this. Right? So that you see on the bottom the distance traveled by the train. Okay. The question states that it says, assume that the train travels the same distance as the car. So that means the distance the car travels is equal to the distance the train travels. So then basically we want to do, let's copy, paste. So this is equal to that. Okay. So now at this point we have one equation, one unknown we can solve. I'm a fan of clearing out the decimals first, so I'm going to multiply the left and the right by the appropriate power of 10 to remove the decimal. So I'm going to say the left by 10 and the right by 10. This takes a little bit of practice. I know this tends to trip students up a little bit, but when you get it, it's a lifesaver. But you don't have to do it this way. This is just the way I like to do it. So then you say 9r equals 5 times r plus 24. So what this is an equivalent equation that's going to have the same solution set. So if we continue to solve, we're going to distribute this 5. So then I'm going to continue on this page. We have 9r equals 5r plus, what is that, 120, right? Then we subtract the 5r on both sides. So then we get 4r equals 120. Divide both sides by 4. So then the rate of, I think this is the car, what is that? 630? Yeah. 30 miles per hour. Let's see. Okay. So our claim is that the rate of the car is 30 miles per hour. The question says, find the distance he travels to work. Find the distance, right? So then if he's traveling at 30 miles per hour, so then the distance is going to be 9/10 of 30. So 9 times 3 is 27. That would, sorry, said the right thing, wrote the wrong thing. That would make it smaller, then that would make it bigger. So it should just be 27 miles. All right. And then we can check that this makes sense. Make sure we get the same thing as for the train. So if R is 30, then 30 plus 24 is 54. It's 27 miles. So we get the same distance if we plug this into either case. Okay, so we just, this is a reasonable answer. He can travel 27 miles. If he's doing 30 miles per hour, he could be on the street. It's a reasonable answer. It's a reasonable distance. So, and we checked it in both. That's about the best we can do here. And on that note, we will end this session here. And from one beautiful mind to another, enjoy the rest of your day.